So this data represents the 2009 crime statistics by state. We're going to draw a box plot of the violent crime, number of violent crimes in each of the states. To do this, we select graphics, and then we select box plot. Graphics, then box plot. We will draw a box plot of violent crime. Click Next. And I personally like to draw the boxes horizontally rather than up and down vertically. And we're also going to use fences that we just talked about to identify outliers. They will show up in the graph. We will label the x-axis violent crimes, title it violent crimes by state. Click Create Graph, and there are your violent crimes by state. And so you can see the outliers are marked by these dots. And if you wanted to know which states correspond to those dots, you can click your mouse button and draw a square over the observation. It becomes magenta, and then within the actual data set, that particular observation will light up. So that's California with the most violent crimes. Now, why do you think California has the most violent crimes? Which state is the most populous?
Yeah, they have more people.
Yeah, they have more people. And so it's really not fair to cast blame about California being violent because it's so violent because of the sheer size of its population. So reporting number of violent crimes is not a fair comparison. Instead, what should be reported is crime rate, number of crimes per population. Okay? And so we could actually create a violent crime rate go to Data, Compute Expression. And the expression that we're going to compute is violent crime divided by population. I'm clicking Add Column as I do this. And hit Compute, and there I get it. So this is number of crimes per population. I could have flip-flopped this and done population per violent crime and say number of individuals per violent crime as well. And now if I do graphics, box plot, violent crime per population, draw horizontally, use fences, and this is basically crime per capita is what we call it, per capita. So violent crimes per person, basically. And now there's our data. And what's really neat, if you look back, you can actually, in this one, you can see where California lies now. Now they're not an outlier at all. Interesting, huh? So let me deselect that from my data set. And here I have an outlier. So let's see what that one is now. Go back here. Let's see where it's highlighted in the data set. Washington, D.C. Notice that we're given the data by region. You see that? Or by geographic division. But let's just focus on region. One other thing that we could do, let me deselect that. One other thing we could do is draw box plots of violent crime per population, but we could group by region. So a separate box plot is going to be drawn for each region, the Midwest, the South, so on and so forth. And so that would allow us to do some sort of a comparison within the different regions of the country. So I'll just click next and do these two, and then title is going to be violent crime by region, right, of the country. Crime per capita is the axis label, and create the graph. And so now you got the 4 different regions: west, south, northeast, midwest. Here's an outlier in the south, which is still District of Columbia. And another interesting thing is, well, what do all these different things mean within the box plot? The reason it's called a box plot is because of this box. Sometimes this is called a box and whisker plot. This observation right here for the west would be the smallest value within the data set, so the min. The left edge of the box is the first quartile, Q1. The middle bar in the box is the median, or Q2. The rightmost edge of the box is Q3, the third quartile, and then this would be the largest observation, the max. And so you can see that for the west, the northeast, and the midwest, the median is roughly the same, right? But the median appears to be higher for the south region. So more violent crimes per capita in the south than in the other 3 regions it would have seen from this graphic.